atom? Yes, it turns out to be so. All right, so let me talk about things which are somewhat weirder, and that is charges. These are exceptions to the number of bonds rules. So remember I said that certain atoms make certain numbers of bonds. There are two things that we care about. In Bio 111, it's oxygen and nitrogen only. The world is an interesting and complicated place. When you take more chemistry, you'll learn about other exceptions, but it's just these. And so normally we say, so oxygen can be either of the following. It can be, this is the familiar oxygen that we've seen. Okay? It can be, that is, it makes two covalent bonds. It has two lone pairs, and there's no charge. On the other hand, it can also be, and we'll see these in biology, this thing has one covalent bond, it has three lone pairs, and it has a single negative charge. Right? It's just a weird thing. I want to do nitrogen, and then I want to talk about a little bit what the deal is on these, because this tends to cause people grief, and rightly so. Nitrogen can be either of the following two structures. It could be the familiar nitrogen that we've drawn, three covalent bonds, one lone pair, and no charge. Or it can be this, sort of analogous in a way. It can make four covalent bonds, have no lone pair, and a single positive charge. Okay? And there are two questions you might well ask about this. Number one is why? And I'll explain that in a second. And the second one is, oh my goodness, how am I going to use this in class? Let me talk about the details first. Carbon and hydrogen, simple. Hydrogen makes one covalent bond, period. Nothing else. We never mess around with any other situations. Carbon, four covalent bonds, period. End of story. Oxygen and nitrogen have two possibilities. They make the one that makes sense, which is the one on the left. Oxygen, two covalent bonds, two lone pairs. Nitrogen, three covalent bonds, one lone pair. Right? No charge. There are these exceptions. Why do we bother? Because these turn out to be wicked important in biology. We see them all the time. Right? So that's why we bother with them. Why are they charged? The answer is that's like 2 lectures in chemistry that I feel like the chemists are going to do a better job at than I am. So what I'm just going to say, so for some of you can say it just is, and I'll show you how to use it in a second. For those of you who it drives crazy to not know why, and I'm one of them, there's a term you can Google, which is, or look up on Wikipedia, it's called formal charge. And if you look up formal charge, you don't have to know it. But if you're curious, if it makes you crazy not to know why, you can look it up. The explanation is not extremely hard, but it's not part of biology. So the more important issue is how do you use them? How to tell which to use. That's the big one, right? There are 2 things. A will tell you, that is, I'll give you a molecule that has a charge, and then you can draw the structure of it. Or B, you can figure it out from the formula and the rules above. All right? So what I'd like you to do Let me write that more neatly again. The rules above. Just take a second and talk to your neighbor. I'm going to give a couple of molecules, and they might be charged. All right? These guys might be charged. The thing is, if you follow the rules, so that if you take a nitrogen and you put 4 hydrogens around it, which kind of nitrogen is it? Is it the kind that's going to have the charge or the kind that's not going to have the charge? Likewise, if you make 1 oxygen and 1 hydrogen stuck together, what's it got to be following those rules that I put up there? And then this one's a little bit trickier. So take a second, try to put 4 hydrogens around a nitrogen. Which one is it going to have to be? Talk to your neighbor, et cetera, and then we'll think about OH and the CH5N. So think about it, talk